Now coming to the cycles used in the automotive engines like Otto cycle and diesel cycle, which are used in SI and CI engines. Now before actually getting into those cycles, let us first understand the reciprocating engine and its part in detail. So here we have the reciprocating engine, you can see here. So here we are having a cylinder, we are having a piston which is reciprocating inside the cylinder and which actually is driven by the crank mechanism, as you can see here. We are having an inlet valve from where air fuel mixture or the air gets inside, an outlet valve from where the exhaust gases gets outside. Then we are having a spark plug in case of SI engine, and in case of diesel engine we are having the injection plug. Now this piston will travel between two extreme ends, and those extreme ends are known as dead centers. The upper extreme end beyond which the piston cannot go is known as top dead center, and the lower extreme end below which the piston cannot go is known as bottom dead center. So the piston always travel between this top dead center and the bottom dead center, and the distance between this top dead center and bottom dead center is known as stroke. And the volume which the piston is traveling while traveling from the volume which piston is covering while traveling from top dead center to bottom dead center is known as swept volume. The volume which the piston is sweeping while traveling from top dead center to bottom dead center is known as swept volume, and the diameter of the piston is known as bore. So we are having a stroke, the length between the top dead center and bottom dead center, that is stroke, and what is the bore? The diameter of the piston, or you can call the inner diameter of the cylinder, is known as bore. Now the minimum volume of this cylinder, that means the volume when the piston is at top dead center, that minimum volume of the cylinder is called as the clearance volume. The volume when the piston is at top dead center, we are having certain volume in the cylinder, that minimum volume is known as the clearance volume. Now there is a term called as compression ratio. Now what is a compression ratio? Now in the compression stroke, as we will be studying this, at the beginning of compression stroke the piston is at bottom dead center, BDC, and at the end of compression stroke the piston is at TDC. So what is compression ratio? Compression ratio is nothing but the ratio of volume of the piston before compression to that of the volume after compression. So below compression we are having the volume, the maximum volume of the cylinder Vmax, and after compression the cylinder is having the minimum volume which is called as V minimum, or the clearance volume, what we call as. Okay, so the ratio of this Vmax to V minimum is nothing but the compression ratio. Similarly, the swept volume we can determine. What will be the swept volume? Swept volume is nothing but the volume which the piston is sweeping between TDC to PDC. So what will be the magnitude of swept volume? That will be equal to pi by 4 d square into L, where d is the bore diameter and L is the length of a stroke. Now next important term is the mean effective pressure. Now what is the mean effective pressure? So during expansion stroke we will be looking into the working of this 4-stroke engines, and you will understand this thing clearly. During expansion stroke the pressure at every point is changing. Now if I assume some constant pressure throughout the cycle such that the same constant pressure will produce the same work output as is produced in the original cycle, that constant pressure is nothing but the mean effective pressure. Mean, what is called as mean? Mean is nothing but the average. Suppose there are 5 students in the class and they are getting different marks. Let's suppose one is getting 10 marks, second is getting 20, third is getting again 20, then we are having 30, then 40 marks. So these are 5 students which are getting different marks. If I want to determine the mean, what I will do is I will add all those marks and divide it by 5. That will be the mean mark. What is the significance of this mean mark? What is the significance of this average mark? If I multiply this average again with 5, I will get the total, same total as the total of the 5 students were having. Okay, so this is nothing but mean. If I maintain a constant pressure throughout the cycle, what would be that constant pressure such that the work done is same as that of an original cycle? That constant pressure is nothing but the mean effective pressure. Now how can we determine this mean effective pressure? So as we know, net work done, W net, is nothing but force into the distance travelled. So this will be equal to F net into the distance L, the stroke length L. Okay, now this force can be written as pressure into area. So we will get this as P into A into L, where P is taken as the mean effective pressure. Okay, so this P is nothing but mean effective pressure into area into L. Now this area into L is nothing but swept volume, as I have told you. Area is nothing but pi by 4 d square L into the length of a stroke is nothing but the swept volume. Okay, so from here we can determine this mean effective pressure, which will be equal to W net divided by swept volume. So this is how we can determine mean effective pressure. Net work done divided by swept volume is nothing but the mean effective pressure. Okay, now coming to the working of this 4-stroke SI engine. SI engine is called as the spark ignition engine, which is also called as the petrol engine, because the fuel which is used in this SI engine is the petrol. Okay, now the very first thing, why such engines are called as the 4-stroke engine. We have got two types of engines, one is 4-stroke engine and second is 2-stroke engine. So what is this 4-stroke and 2-stroke engine? 4-stroke engine means during one power cycle, the engine travels the stroke 4 times. Okay, I have told you about this stroke. The distance between TDC and BDC is nothing but a stroke. So when the piston is traveling from suppose TDC to BDC, it is called as 1 stroke. Then it travels from BDC to TDC, it is 2nd stroke. Then TDC to BDC, 3rd stroke. Then BDC to TDC, 4th stroke. So these are called as the 4 stroke. During one power cycle, during one cycle, the piston travels the stroke 4 times. Then it is called as the 4-stroke engine. And if during one power cycle, if the piston travels the stroke only 2 times, then it is called as the 2-stroke engine. So the petrol engines which are used nowadays in most of the vehicles, we have got the 4-stroke engine in all the bikes, in all the scooters, in everywhere we use this 4-stroke engine. In the previous, a few years back, we were having the scooters, and then we were having the scooties, the TVS scooty. All such engines which were used there was a 2-stroke engine. The engine which was used in the Bajaj scooter, LML scooter, those engines were the 2-stroke engines. But now all those engines are almost everywhere, they are replaced by the 4-stroke engines. Nowadays we are using the 4-stroke engine only. So we are having the 4 strokes here. The first stroke is the suction stroke, then we have the compression stroke, 2nd stroke, then 3rd stroke is the expansion stroke, and 4th stroke is the exhaust stroke. So these are the 4 strokes. Now I will tell you the functioning of this 4-stroke engine, 4-stroke SI engine in detail. So in the very first stroke, the initially piston is at TDC, top dead center. The first stroke starts from there and the piston travels from TDC to BDC. This is the first stroke. This is called as the suction stroke. Why this is called as the suction stroke? Because in this stroke, the inlet valve opens and the fuel air mixture comes inside from the carburetor. In carburetor, we are having the arrangement such that the fuel and air get mixes, the petrol and air get mixes, so that petrol air mixture, the fuel air mixture gets inside to this cylinder during this first stroke. So what happens in the first stroke? The piston traveling from TDC to BDC, and in this process the inlet valve is open and the fuel air mixture gets inside. This is the first stroke. Now at the end of this first stroke, the inlet valve is closed. Now the crank further is rotating, which will cause the piston to move from BDC to TDC. Now the inlet valve and exhaust valve, both valves are closed. The piston is moving from BDC to TDC. The air fuel mixture which is inside that cylinder, it will get compressed. The volume is decreasing, it is getting compressed, and at the end of this second stroke, this stroke is called as the compression stroke, because the air fuel mixture is getting compressed. And at the end of this stroke, we are having a compressed mixture, a high pressure, high temperature mixture. Then at the end of this stroke, the spark plug will produce a spark. And in that high temperature, high pressure mixture, a small spark will cause the combustion, will cause the fire. So it catches fire, the combustion process happens, and the complete air fuel mixture gets combusted. Now after that air fuel mixture gets combusted, then it will try to expand. Okay, so third stroke is the expansion stroke, in which the piston is again moving from TDC to BDC. This is the main stroke, which is called as a power stroke. That means the power is derived from this stroke only, and rest of the 3 strokes are the idle stroke. This is the main stroke, the power stroke. So the piston is traveling from TDC to BDC, the power is produced, the work is done. Now at the end of this power stroke, the exhaust valve will open and the heat inside the cylinder will be rejected. And after that, the piston will move from BDC to TDC, and which will get all the exhaust gases which are inside the air, that will get out from the exhaust valve. Okay, so this is the whole functioning of this cycle. Then after that, the inlet valve again opens, the fuel air mixture again gets in, and this cycle continues. Okay, so I will tell you once again, in the first stroke, the piston traveling from TDC to BDC, the inlet valve opens, air fuel mixture gets inside. This stroke is called as the suction stroke. Then at the end of this suction stroke, the inlet valve closes, the piston will move from BDC to TDC and it will compress the mixture, the air fuel mixture will get compressed, and at the end of this compression stroke, this second stroke is called as compression stroke. At the end of this compression stroke, there will be a spark from the spark plug, which will cause the fuel air mixture inside the cylinder to get combusted, okay, and then that will be expanded. After that the fuel air mixture is combusted, it will be expanded. There comes the third stroke, which is called as the power stroke or the expansion stroke, and the piston will travel from TDC to BDC. Then after third stroke, the exhaust valve will open, the heat will be rejected, and then the piston will travel from BDC to TDC and driving all the exhaust gases, the waste flue gases, driving all those flue gases gets outside from the exhaust valve. So this is how the 4-stroke engine works. Now the important thing to note here is, here the heat addition and heat rejection ideally is assumed to be at constant volume. There is a constant volume heat addition and constant volume heat rejection in this case, in case of this SI engine in Otto cycle. Okay, now what does this mean? What is the meaning that the heat is added at constant volume and heat is rejected at constant volume? Obviously this is not in the case of actual cycle, but ideally we assume it to be at constant volume. Now what does this mean? This means that after the compression stroke, when the piston gets it to the top dead center, then the spark plug produces a spark and the fuel air mixture start combusting, and that combustion process is at constant volume. At constant volume means our piston will stay at TDC, the whole of the combustion process will take place, and then after that the piston will start moving from TDC to BDC. This is the meaning of constant volume. That means the piston will stay at TDC till the complete combustion process happens, and then it will move from TDC to BDC. Similarly, heat rejection is also at constant volume. Now what does this mean? This means that the piston is at BDC, complete heat is rejected as the exhaust valve is open, complete heat is rejected, and when that heat is rejected, then after that we are having the exhaust stroke, in which the piston will move from BDC to TDC and driving all the flue gases outside. So these are two important things here. So this is how the SI engine functions, and the cycle used in this SI engine, in a spark ignition engine or petrol engine, the cycle which is used is called as the Otto cycle.